Good morning all, my name is Santosh kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about logic micro operations. So, logic micro operations are binary micro operations implemented on the bits saved in the registers. These operations treated each bit independently and create them as binary variables from them. For example, the exclusive OR micro operation with the contents of two registers R1 and R2 is denoted by the statement P tends to R1 to R1 XOR R2. So it determines a logic micro operation to be implemented on the single bits of the registers, supported that the control variable P equal to 1. Consider that the each register has a 4 bits. Let the content R be the 1010 and the content 2 be the R2 equal to 1100. So what are the logic micro operations are there? So logic micro operations, when I'm going for the logic micro operations, it is only with binary numbers only it is possible. When it is going for the binary numbers only. So what are the logic micro operations? So AND gate, OR gate, NAND, NOR, XOR, XNOR. So these are we are considering as a logic gates. So through the logic gates only we are performing. Through these gates performing the logic of through these gates logic operations to be performed. When applying the logic gates, we are performing the logic operations. That is called the logic micro operations. So if we have the logic gates are there, so how can we implement means through the instructions only it is possible. So that is called logic operation. So when I'm using the logic gates with the instructions, I'm performing the operation micro operation. That is a logic micro operation. So logic micro operations are binary micro operations implemented on the bits saved in the registers. These operations treated each bit independently and create them as binary variables from them. So some example, we have to take one exclusive OR micro operation with the contents of two registers R1 and R2 denoted by the statement R tends to R1 plus R2. It determines a logic micro operation to be implemented on the single bits of the registers, supported that the control variable P equal to 1, and consider that each register has a 4 bits. Let R1 equal to 1010 and R2 equal to 1100. So I am using exclusive OR gate to perform the micro operation with the content of two registers, that is R1 and R2. So I am using two registers to perform logic micro operation. So what is a logic operation means? R1 XOR R2. So what is the resultant value? It is stored in R1. Okay. So R1 XOR, I am performing XOR gate to R2. So what is the resultant value? After applying the XOR, the resultant value is storing in R1. Okay. Here R1 equal to I am taking 4 bit 1010, R2 equal to I am taking 1100. So if you are taking the R1 equal to 1010 and R2 equal to 1100, the resultant value XOR is performed in 0110. So this result value stored in R1. So the exclusive OR micro operation started above represent the following logic operations: R1 equal to 1010, R2 equal to 1100. The resultant value stored in 0110. So this result value is stored in R1. So the total 16 micro operations are available in the logic micro operations. So what are the 16 logical operations? 16 logical micro operations. First one, 0 tends to F. That means clear. There is no data is there. And if I am going for the AND logic gate, AND means A into B. I am going for the A into B. F tends to A into B. Okay, it is a like this, and A into B bar. So F into A into B bar. A into B bar means B bar is nothing but a NOT gate, that is a complement. So how many logic gates here performing means here A into B. A into B bar means here AND gate, and B bar means I'm using NOT gate. So here two logic gates are using. Here F tends to A means the data is transferring of A to another register. Next A complement B. A complement B means NOT gate applying here, and here AND gate is applying. So and NOT is applying. Two gates are applying here, and here it is a B tends to F means the transfer of B to the another register. Here A XOR means exclusive OR gate is performed to the A and B logic gates. And here OR gate. OR gate means A plus B. So F equal to A plus B. And NOR gate. That means A plus B whole bar. So what is that meaning means OR gate and NOT gate both are using here. Here exclusive NOR means NOR and NOT gate are using here. So exclusive NOR means A into B bar plus A bar into B. So it is a complement of B. Complement of B means here I am using NOT gate to the B. NOT gate of B. So suppose here it is a NOT gate. What is answer? B bar. Here I am taking 0. What is answer? 1. I am taking given 1. What is answer? 0. So it is called NOT gate. A and B. What is answer? A plus B. So what is the gate here? OR gate. A, B. What is answer? A into B. So what is the logic gate here I am using? AND gate. So previously we got F equal to A into B bar. That means A into means I am giving here AND gate. B bar means I am using NOT gate like this. So and NOT both are logic gates are using for this operation. So here complement of A means NOT gate, NOT gate of A, that is a complement. So here NAND gate. So that means AND of like this. So not of AND. So A into and NAND gate means what is a NAND gate here? Here NOR and NAND gate. NOR gate is there. So when I am applying the NOT gate means AND plus OR, AND plus NOT, that is a NOR gate. So here NAND gate, and here all ones complement. When I am going for the subtraction like this, suppose I am taking ones complement of this one. Ones complement of A, that means suppose I am taking A equal to 1. So one complement of A equal to 0. That means complement and A bar means. So here suppose I am giving A equal to 0. So what is the complement? A equal to 1. So one's complement means I am using NOT gate here and complementing of these values. The above table shows the 16 logic microoperations mentioned there, and X and Y are the variables of registers in the data stored in F0 to F15 are the outputs that occur after performing these logic micro operations. So what are the inputs values? 0, 0, 0, 1, 1, 0, 1, 1. So what are the 16? F0 to F15. F0 to F15 means total 16 logic micro operations are mentioned above. So X and Y are the input values and F0 to F15 are the output values are performed. So these are the logic micro operations. And hardware implementation. The hardware implementation of logic micro operations requires that logic gates be inserted for each bit or pair of bits in the registers to perform the required logic function. Although there are 16 logic micro operations, most computers use only 4 AND or XOR and complement of each. All others can be considered. The next figure shows the stage of a circuit that generates the 4 basic logic micro operations, and it consists of 4 gates and a multiplexer. Each of 4 logic operations is generated through a gate that performs the required logic. So here the hardware implementation means the hardware implementation of the logic required that logic gates of insert of each bit or pair of bits in the register are to be performed in the required logic function. So hardware implementation. What are the hardware implementations? I am going for the AND gate. So A into B. OR gate. A plus B. NOT gate. A means A bar, B means B bar. So these are the hardware implementation, means logic gates physically I'm using for the logic operations, and these logic gates are inserted of each bit or pair of bits in the registers to be performed. And although there are 16 logic micro operations to be performed, so 16 means 4 and 4 or 4 XOR and 4 complement. Total 16 logic gates are to be performed. And the below figure shows the circuit that generates 4 basic logic operations to be consisting, and it has the 4 gates and multiplexer. Each of the 4 logic operations are to be through gated as a required logic. So hardware implementation of this logic, I am taking here multiplexer. So what is multiplexer? Mux means multiplexer. So in the multiplexer, n is to 1, n inputs, 1 output. Any number of inputs you have to take, only one output will be get. That is a n inputs and only one output. That is a multiplexer. S0 and S1 are the two switches are there. S0 and S1. So multiplexer here 4:1 means 4 input lines are there. Only one output will be there. That is a 4:1 multiplexer. So what are the logic gates I'm using means here? AND, OR, XOR, NOT gate. So previously here discussed 16 logic gates of 4 and OR, XOR and complement of each can be derived. That is a 4:1 multiplexer. So in this 4:1 multiplexer, how many inputs are there? 4 inputs, 0, 1, 2, 3, and OR, XOR, NOT gates I am taking, and 2 switch conditions are there. Switch means S0, S1. If it is 0, 0, what is the operation? 0, 1, 1, 0, 1, 1, like this. So how many possibilities of there? So that is a switch condition. So 0, 0, 0, 1, 1, 0, 1, 1. So these are the 4 stages are there. One stage of logic circuit. If I am taking 0, 0, what will be enable? AND will be enable. 0, 1, OR will be enable. 1, 0, XOR will be enable. 1, 1 means NOT gate will be enable. Here AND get enable, OR get enable, XOR get enable, complement will be enable. So that is the advantage of this one. So here what are the inputs are there means A, B are the 2 inputs are there. Inputs of logic gates. So 4 logic gates of 4 inputs, 4:1 multiplexer, 1 output is there. So I am taking 4 inputs. So these hardware implementation, it consists of 4 gates and a multiplexer. 4 gates I am taking and 1 multiplexer. And these logic operations are generated through a gate that perform the required logic. The outputs of the gates are applied to the data inputs of the multiplexer. The 2 selection inputs S1 and S0 are the data inputs of the multiplexer and direct its values of the output values. So what are the data lines are there? Data lines to be enabled through the switches, that is S0 and S1. So these output of the gates applied to the data inputs of the multiplexer. Multiplexer means only one output I am getting from the 4 logic gates of the inputs. These 2 selection lines are S1 and S0 is the another data inputs of the multiplexer and direct its values of the output. And the diagram shows that the logic circuit with n bits, and the diagram must be represented in n times for I equal to 0 to n minus 1. And what are the applications of logic micro operations? The logic micro operations are very useful for manipulating individual bits or a portion of a word stored in a register, and they can be used to change the bit values of or delete a group of bits or insert new bits of the register. So selective set, complement, clear, mask, insert, clear. So when I'm going for the applications of logic micro operations, these micro operations are manipulating individual bits or a portion of this one. So they can be used to change bit values, delete a group, or insert a new bits of the register. So how can we add, how can we delete, how can we edit, how can we change the register values? So these are the 6 techniques are there: selective set, selective complement, selective clear, mask, insert, and clear. So already we discussed these are the inputs of the logic gate: and, or, XOR, NOT, 4 logical input gates to the multiplexer. So if I'm taking 0 0, the value is 0. Why? Because 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 1 1, and or 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1. XOR 0 into 0 0, 0 into 1 1, 1 into 0 1, 1 into 1 0. So when I'm going for the XOR gate, means A into B bar plus A bar into B formula applying here. NOT gate means complement. If I'm giving 0, output is 1. If I'm giving 1, output is 0. That is a NOT gate. So total 4 logical gates are applied to the multiplexer. And selective set, first method is a selective set of the logical micro operation applications. The selective set operation sets to 1 the bits in register A, where there are corresponding ones in the register B, and it does not affect the bit position of zeros in B. So the following numerical examples clarifies the operation: 1010, 1100. So in the selective set, I am applying the OR micro operation. OR means A, B, A plus B. So if I am giving A before B logical operand, what is the operand here you are using? OR gate I am using. That is a OR gate. That is a operand. So here 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1 plus 1, 1. So 1, 1, 1, 0. I am getting through the micro operation, I got this value. That is a selective set. And selective clear. Selective clear means the selective clear operation clears to 0 the bit in A only where there are corresponding ones in B. For example, 1010, 1100. So it is a before value and B logical operand and A after. The corresponding logical micro operations are A tends to A, B. Means I am using here what is the symbol in the diagram. It is already mentioned. We can see once what is the operation here, and so this symbol means I am giving A into B. So selective clear I am using AND operation. So 0 into 0, 0. So like this, the corresponding logic operation is like this, and the selective clear operation is clears 0 bits only A corresponding A once in the before the example. So it is clear operation. Selective clear means it clear the all the operations of this one. We are not performing any AND operation. Why? Because here already clear will be there. So A only corresponding to the ones in the B example. So here I am taking 1010 of A, and B logic operand I am using any of the operand you can take here. So here I am taking 0 0 0 1 0 1 0 1 0 1 1 means 0. So when I am using this operation, and mask operation. the mask operation is performing similar to the selective clear operation, except that the bits of A are clear only where there are corresponding zeros in B. The mask operation is AND micro operation as seen from the following numerical. A and logical operation of B, I am applying the mask operation, means AND is performing here. So when I am going for the 0 into 1, 0, 1 into 1, 1, 0 into 1, 0, 1 into 1, 1. Okay. So this 0 into 0, 0, 1 into 0, like this. So when I'm applying the AND is there, but I got only one value, only A register I need. Another B register I'm taking our own. That means higher order values I'm taking 0, 0, 0, 0, lower order values I'm taking 1, 1, 1, 1. So this is I'm taking our own B's. So I'm applying the A value already given 0, 1, 1, 0, 1, 0, 1, 0. B I'm taking as a higher values are all zeros, lower order values are ones. Then only I'm applying AND operation, means multiplication of this one. So then only I will get the operation. That values are called mask operation. So insert means after getting the mask, we are continuing the operation. So first we have to apply the mask, then only we'll go for the insert operation. So the insert operation, a new value into a group of bits. This is done by first masking the bits and then ORing them with the required value. Suppose I'm taking A register has a 0, 110, 1010. These are the input values. These are replacing with the leftmost bit is a 000 and the value is 1000. We can mask the 4 unwanted bits. So the input is given 0, 110, 1010. 0, 110, 1010. It is the value of A. So in the mask means what I have to do, higher values are taking 0, 0, zeros, lower values are taking 1, 1, 1, 1. So first I have to go for the AND operation. Okay. So AND means 0 into 1, 0, 1 into 1, 1, 0 into 1, 0, 1 into 1, 1. Here 0 into 0, 0, 1 into 0, 0, 1 into 0, 0, 0 into 0, 0. So it is the mask output. This is called masked output. Masked output, not insert value. After the getting the masked value, I am going for the, what is the masked value? 0, 0, 0, 0, 1, 0, 1, 0. Okay. So I am giving the inserting of these values of anything. You have to take any of the value 1001, all zeros. Here lower values are reverse. Here higher order values are converting to the lower order values, and after then I am going for the OR operation. 0 plus 0, 0, 1 plus 0, 1, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, 1. What is output here? It is a insert output. This is called inserted or insert output. The mask operation is performed, and after the mask I am applying the OR gate, that is called insert. Next one is a clear. The clear operation compares the word in A and B and produces an all zeros. The result of the two numbers are equal. This operation is achieved by exclusive OR operation. So when I am going for the 1010, it is a value. So again I am taking 1010, that is a logical operand. So after getting I am doing 0000. So it is the exclusive OR operation. A into B bar plus A bar into B. That is the XOR operation I performed with A and B. So it is a final value. And these are the references of this one. So here we discussed here the applications of logic micro operation: selective set, selective complement, selective clear, mask, and insert and clear. So in the selective set, which gate we are applied? We are applied here OR gate for the selective set. And here clear operation is applied, and here mask means I am applying the AND gate. Insert means first AND, after then going for the OR. Clear operation means we are applying the XOR logic gate to the clear operation. So the logic operations are binary operations implemented on the bits saved in the registers. These operations treated in the independent of the create of the binary values. For example, I'm taking exclusive OR operation. So R1 to exclusive R2 of what is the result value tends to R1. So XOR gate input A and B and getting the output. So that is a R1. This R1 tends to R1. The resultant value is tends to R1. It determines a logic micro operation to be implemented on the single bit of the register supported that the control variable P equal to 1 and the register of 4 bits have the R1 equal to 1010 and R2 equal to 1100. Here I am taking 1010 is an input value, R2 is another input value 1100. Applied exclusive OR gate, what is the result value? 0110. So these are the 16 micro operations are there. That is clear. And transfer of A means A complement, B complement, exclusive or NOR, exclusive NOR, complement of A and complement of B, NAND gate and ones complement. These are the 16 micro operations are performed. These are the two inputs 00, 01, 10, 11 and remaining are the 16 logical gate outputs are there. F0 to F15. And what are the logic gates I need? Hardware. So AND, OR, NOT, NOR, NAND, XOR, XNOR, these are the logic gates I need. That is a physically I need. That is a hardware implementation of 16 logic gates. And it is a performance of logical gates or 4 logical gate inputs and multiplexer I am getting for output of 1. So 4 inputs, 1 output. So what are the 4 inputs means? AND gate or XOR NOT gate. So these are the logic gates A and B. S0, S1 are the switch conditions 00, 01, 10, 11. 00, 01, 10, 11. So for 00 AND gate is enabled. This one is enabled for output. So 2 inputs. How many inputs are performing? 2 inputs. For this one, only 1 output I will get. So when I'm going for the 01, OR gate is enabled. 2 inputs are applied. Only 1 output will be getting. Okay. It is a 10 means XOR is applied. So XOR is applied. 2 inputs are there. Only 1 output is there. And complement means only one input is possible. 1 input and getting 1 output. 1 output. So it is about the hardware implementation of one stage of logic circuit with 4 inputs and 1 output. That is a 4 logic gates with multiplexer. And hardware implementation consisting of logical gates and multiplexer. 4 logical gates and 1 multiplexer. And the outputs are depends on switch conditions S0 and S1. And the logical circuit with n bits of there and the n times of 0, 1, 2, 3, so on, n minus 1 are there. And these are the applications of logic micro operation: select to set, select to complement, select to clear, mask, insert, clear. So these are the truth tables of AND, OR, XOR, NOT gate. It is a select to set, select to clear, mask, insert, clear. These are the references. Okay, it is about the logic micro operations. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.